Last time we started on section 3.4, we reviewed 3.3, we reviewed long division, we reviewed synthetic division, we talked about the remainder theorem. The remainder theorem says that if you divide by the root, for example, if I wanted to find f of 2, I just needed to do synthetic division by 2, and the remainder is the same as plugging that number in. And then we got into section 3.4. Oh, well, we went over one of these problems also. Solve the equation telling you what one of your answers is. So you divide by one of your answers and then factor what's left over and you get your 3 answers, right? Section 3.4, we talked about possible rational zeros. So on these problems, you're not given any of your answers. You have to find them yourself. And so what we do is we use our P's and Q's to find the possible solutions to narrow our list down from infinity to a smaller set, like 6 solutions or like 8 solutions or something like that. So P's and Q's, the P values is the factors of the number at the end. The Q value is the factor of the number, the leading coefficient. And you divide all your P's by all your Q's to get a set. So like for this problem, negative x to the 4th plus 3x squared plus 4. When we do our P's and Q's, the possible rational solutions are positive 1, negative 1, positive 2, negative 2, positive 4, negative 4. So that's 6 options there versus the infinity options. Okay, so we did 2 problems. Well, we did another one of the possible solutions. This one had a whole bunch more, and a lot of them were fractions, which would be harder to come up with. But the way you solve a polynomial is first you find the possible solutions, and then you cheat, or we are efficient with our time and our resources, and we use that to figure out which one to divide by, like which one's a 0 to divide by. And we do that multiple times until we get a quadratic, and then we solve using quadratic formula or factoring. So we did one problem last time like that. I gave you this problem, x cubed plus 2x squared minus 5x minus 6. We didn't know any solutions here. We know that there are 3 solutions though. So what we did was we found our P's and Q's. My options were positive, negative 1, 2, 3, and 6. I used my calculator to say, oh, I know that 2 is actually a solution here. So since 2 is a solution, I'm going to take my function. I'm going to divide by 2. I should get a remainder of 0, which I did. I know now that 2 is a solution, x minus 2 is a factor. And then this piece that's left over is a quadratic, and I could factor that one to get your other 2 solutions. Okay, so let's do some more of those. Let's practice that a little bit more. So let me find where I'm at. So let's do this next problem. Let's do f of x, and we're just solving this, equals x cubed plus 7x squared plus 11x minus 3. Okay, I don't know any solutions here. How many solutions does it actually have though? 3. Technically, I could have 3 answers down here. X equals, X equals, X equals. I don't know what any of them are, but I know I have 3 of them, right? From that point, we could go up and to get factors. I'm not going to do it right now, but you could have like the 3 factors based on 3 roots, right? Okay, so let's find our possible rational roots here to narrow our list from infinity down to a smaller set of numbers, and then we are going to use our handy dandy calculator to help us pick the right one so that we aren't wasting our time on it. Okay, so P's and Q's, what's my P value here? Yeah, I'm looking for the factors of negative 3. The factors of negative 3 are 1 and 3, right? For my Q, Q is the factors of your leading coefficient. What's your leading coefficient? 1, and so the factors of 1 are just positive and negative 1. So the possible rational solutions is P divided by Q. So all my P's divided by all my Q's. So plus 1 divided by 1 is 1, so positive 1 or negative 1. 3 divided by 1 is 3, so it's positive or negative 3. So I narrowed my list of my options of solutions from infinity down to 4. Okay, either positive 1, negative 1, or positive 3 or negative 3. You could just guess and check to see if it works, which one's the solution. If I did not have a calculator and I was doing this by hand completely and I was guessing to see which one was the solution, what would I do? You pick one and we would divide, use synthetic division, right? You could plug it in, but we're kind of killing two birds with one stone. If it is a root, then I have to divide anyway. So I'm kind of figuring it out both ways. So I would divide, and if I get a remainder of 0, that tells me it's the right one. Okay, and you cross your fingers and hope you pick the right one the first time. Okay, we're going to be efficient with our time, and we're going to type this in our calculator. X to the third plus 7x squared plus 11x minus 3. And I'm going to graph it and see which one I should pick. Okay, if my options are positive or -1, does it cross at positive or -1 at all? Ooh, she's early. Okay, so does it cross at positive or -1 at all? No. Over here, it looks like it crosses at -3, and it almost looks like it crosses at -4 also. So I'm going to use -3, obviously, is the one that I'm picking here, because my options, out of the 4 options, -3 is the only one that looks like it actually crosses. Okay, and that probably would actually have been my last choice, so I'm glad I checked. Brianna, I think you're early for class. You are more than welcome to sit through this class if you want to, but I think your class doesn't start till 11. Okay, so we're going to divide by -3. So again, I put my coefficients here, 1, 7, 11, and -3. I should get a remainder of 0 here. Okay, so I'm going to bring down my 1. -3 times 1 is -3. 7 plus -3 is 4. -3 times 4 is -12. 11 plus -12 is -1. And -3 times -1 is +3. And -3 plus +3 is 0. So we know that -3 is the solution. I can go down to my answers and write x equals -3 as an option there, right? I have 2 more solutions. Where are those at, or how am I going to find those? Because it's not +1, it's not -1, it's not +3. So where else am I going to find my solutions? When you divide, you get this piece left over. This is 1x squared plus 4x minus 1. That tells me this factors into x plus 3, because my root or my solution is -3, times x squared plus 4x minus 1, right? And then now this is a quadratic. I can solve a quadratic by either factoring or using the quadratic formula. Let's see if it factors first, because that's the fastest way to do it. Does this one factor? Do 2 things multiply to get -1 and add to get 4? No. So this one does not factor. That's the reason why I don't have rational solutions here. If it all factors out nicely, you're going to have rational solutions. If it doesn't factor out nicely, that means you have irrational solutions, and you're not going to see these in the P's and Q's. Okay. So since they're all irrational, or since it's irrational, I have to use the quadratic formula to solve it. Okay. So let me use the quadratic formula. So my A, I'm going to do a different color here. A is 1, B is 4, C is -1. So negative B, -4, plus or minus the square root of B squared, so 4 squared, minus 4 times 1 times -1, all divided by 2 times 1. 4 squared is 16. -4 times 1 times -1 is +4, so that's 20. So I get -4 plus or minus the square root of 20 over 2. I have a feeling that's going to simplify. Oh, sorry. So 20 can break down, and what can we pull out of the square root of 20? You come over to the side, 20 is 4 times 5, and the 4 is 2 times 2. I can pull a 2 out. So this becomes -4 plus or minus 2 times the square root of 5 left over on the inside divided by 2. Can I simplify my 3 outside numbers? Yeah, they all divide by 2. So I get negative 2 plus or minus 1 times the square root of 5 divided by 1. So just negative 2 plus or minus the square root of 5. And there's your other 2 answers. What's one of them? Negative 2 plus the square root of 5 and negative 2 minus the square root of 5. So this would be a problem where you have to do this whole process. Like you can't just look at your calculator. Remember that last problem we did last time, how all the answers were on your calculator, like negative 1, 2, and 5 or whatever. This one, you can see negative 3 on your calculator. You can also see these two. I just don't know what they are because they're a decimal. Because if you, let's see, negative 2 plus the square root of 5 is 0.236. Sorry, you can't see that very well. And negative 2 minus the square root of 5 is negative 4.236. And you can see that on your graph. You just don't know what those decimals are. That's the negative 4.236 and that's the 0.236. Okay. Okay, let's do another one. Let's do the problem. Let's do one that's a little bit bigger that we have to divide more than one time. So f of x equals x to the 4th minus 6x squared minus 8x plus 24. How many solutions is this one going to have? 4 solutions. 1, 2, 3, 4. Okay, so again, let's find our P's and our Q's. Our P value is the factors of the constant. Factors of 24, there's a whole bunch of these. Factors of 24 are 1, 2, 3, 4, 6, 8. 8 times 3 is 24. 12 times 2, so 12, and 1 times 24, 24. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. What are my Q values? Or what's my leading coefficient? 1. So the factors of 1 are just 1. When I divide them out, what am I going to get? All the top. Like if that's the case, don't write that again. Just say this is the possible rational solutions. So this is one where we're really glad we have the calculator, because do you want to sit there and guess which one is the option? No, because there's a whole bunch. There are 1, 2, 3, 4, 5, 6, 7, 8. So there's 16 options here. Okay, so let's use our calculator to figure out which one we should guess first. So x to the 4th minus 6x squared minus 8x plus 24. Okay, so I'm only seeing a piece there. Where does it touch the x-axis at? 2. And it does something special. Does it cross the x-axis at 2? It bounces off of that. What does that tell me if it bounces off of it? We know the degree's even here, right? So what does it mean if it bounces off? The multiplicity is even because it does 2 things here. It touches it and then it turns back up. So the multiplicity is 2, 4, 6, 8. It's an even number, right? So that tells me that this answer of 2, it's got to be an answer at least 2 times. Technically, it could be an answer 4 times, right? You can kind of zoom out to see. Okay, so it isn't weird up there, but it only crosses at 2, or only touches the x-axis at 2. So I have 2 options here. X equals 2 could be an answer 2 times, because I know it has to have an even multiplicity, and then the other 2 answers could be imaginary numbers, because I can't see anything there. Or x equal 2 can technically be have a multiplicity of 4 times. Okay, so those are our 2 options here. So regardless, I know I'm dividing by 2, right? Because I know that's an answer. So let me divide it by 2. When we divide it by 2, make sure you're putting your coefficients and make sure you put in a placeholder because I'm missing a piece there. I have 1 is the coefficient for x to the 4th. Do I have any x to the 3rds? No, so you got to put a 0 in. 0, -6, -8, 24. When I divide it or do synthetic division, I bring to my 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. -6 plus 4 is -2. 2 times -2 is -4. -8 plus -4 is -12. And 2 times -12 is -24. -24 plus 24 is 0. Okay, so I know that 2 is an answer. So I can go down to my answer blanks and put 2 as one of my answers. So that tells me this factors into x minus 2 times the leftover part is our answer down here. I started off with x to the 4th, so I'm down to x to the 3rd now. So 1x to the 3rd plus 2x squared minus 2x minus 12. Is that thing that we have right there, is that a quadratic? Does it have x, like is the degree of this 2? No, it's not a quadratic. I cannot use quadratic formula to solve that. It might factor, in this case it actually doesn't. If you factor by grouping, this would be x plus 2, and when I pull a 2 out, this would be x plus 6. And so it wouldn't factor by grouping either. So I'm stuck. If I can't factor it and I can't use quadratic formula, how am I going to get the other 3 answers here? Do it again. I got to do this whole process again. When I divide this time, I'm not starting off with my original problem. I'm starting off with this part right here is what I'm dividing. So I'm trying to get that cubit function degree 3 down to a degree 2. So now I'm going to take this part and let me divide it again. So what am I going to divide by here? Okay, so technically we could do the P's and Q's again here, right? It would still be 2 though. We kind of already figured that out because it has a multiplicity of 2 at 2. So I know it has to divide by 2 twice. I know 2 has to be an answer at least 2 times here. Okay, if you didn't know that, you could, like if this was a different problem where it crossed 2 or 3 different times, you could use one of those answers to divide, or you could do P's and Q's again at this point. If I did P's and Q's at this point, it takes off a couple of my options here. I couldn't do 8 and 3 anymore. I couldn't do 24 anymore. Okay, so it takes off a few of your options that way. So I'm going to divide by 2. This time I'm using my coefficients for my new piece, which is 1, 2, -2, -12. Bring down the 1. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -2 plus 8 is 6. 2 times 6 is 12. -12 plus 12 is 0. That's what we thought. We thought that 2 is an answer again. I could go back down and write 2 as an answer again. And so now I know this factors into x minus 2, x minus 2, because I had 2 as an answer 2 times. And then the leftover piece, x squared plus 4x plus 6. Does this quadratic, like now we have a quadratic. Now we're down to like the end of the problem. Does this quadratic factor? Are there 2 things that multiply to give me 6 and add to give me 4? 6 is 3 times 2 or 1 times 6. Do either one of those add to give me 4? So obviously this is not the situation where I had 2 as my answer 4 times. Okay, so I need to solve this using the quadratic formula now. Okay, so I'm going to do quadratic formula here. So negative b, -4, plus or minus the square root of 4 squared minus 4 times 1 times 6, all divided by 2 times 1. 4 squared is 16. 16 minus 24 is -8. Is that right? I've been up for a long time today. I'm 16 minus 24. Yes, -8. So I get -4 plus or minus the square root of -8 over 2. I can simplify that some more. If you like came over the side, 8 is 4 times 2, which is 2 times 2. I can take out a pair of 2's and there's a 2 left over on the inside. What about the negative? Comes out as an I, right? So this would be -4 plus or minus 2i times the square root of 2 over 2. And that simplifies some more. That is all the outside numbers divided by 2. So -2 plus or minus I times the square root of 2. So that's my other two answers that I could not see on my graph. -2 plus I times the square root of 2. -2 minus I times the square root of 2. So that's your 4 different answers there. Questions about that? Okay, let's do one more. Just a second, let me get the next problem. Minus. And let's see. Plus minus 2x. Okay, sorry, just a second. I'm gonna do it like this. Let's see. Okay, so it is. So this is number 3. X to the 4th minus 2x cubed minus 16x squared plus 2x plus 15. That's f of x. Minus x squared. Okay, so first thing we're going to do, how many answers are there here? 4 different answers. 1, 2, 3, 4. Okay, let's narrow our options down from infinity to a smaller set by doing P's and Q's. What is the factors of the constant term? What's the factors of 15? 1, 3, 5, 15. What are the factors of the leading coefficient of 1? Yeah, 1. So when I divide them out, what is my P divided by Q, my possible rational solutions? All the P's. 1, 3, 5, and 15, positive and negative. So I have 8 options here. Let's put this in our calculator to see which one we should choose first. So when I put it in my calculator, 2x to the 3rd minus 16x squared plus 2x plus 15. Okay, so it looks like it crosses at -3, -1, +1, and 2, 3, 4, 5. So pick one, it doesn't matter. What do you want to pick? 5. I pick one. You can do whatever. Let's pick 5. So I think that 5 is an answer. Let me go ahead and divide before I write it down as an answer, just to verify that it's an answer. Okay, so my coefficients are 1, -2, -16, +2, +15. So bring down the 1. 5 times 1 is 5. -2 plus 5 is 3. 3 times 5 is 15. -16 and 15 is -1. 5 times -1 is -5. 2 plus -5 is -3. 5 times -3 is -15. And +15 and -15 is 0. That's good. That tells me that 5 is an answer. Okay, so since 5 is an answer, that tells me this factors into x minus 5. And then I started off with x to the 4th, so now I have x to the 3rd plus 3x squared minus 1x minus 3. Look at this cubic function we have right here. Does that look like it factors? Yeah, it factors by grouping. They don't always do. It's only because you pick, if we would have picked 1, this would not have factored by grouping at this point. But this one actually does. If it can factor by grouping, have at it. Like, that's much shorter than dividing. What if it didn't factor by grouping though? You got to do synthetic division again. Like, if pretend like you didn't factor by grouping. At this point, I would take these numbers and divide it by one of my solutions. I would divide it by -3, -1, or 1 at that point. Okay, but in this case, we lucked out. It factors by grouping, so let's factor it by grouping. X cubed plus 3x squared, what can I take out? X squared. Left over is x plus 3. -1x minus 3, I can take out a -1. Left over is x plus 3. So this factors into x plus 3 times x squared minus 1. I still have this x minus 5 in front, right? So that tells me another one of my solutions. I know that 5 is a solution. This factor of x plus 3, when I set that equal to 0, what do I get? -3. There's 2 ways you can get this last one. This is a quadratic. It actually factors. What does x squared minus 1 factor into? Difference of 2 squares. X plus 1, x minus 1. Right? And that tells me 2 solutions. Or you could use quadratic formula, or you could solve using square roots. Move the 1 over, take the square root, don't forget the plus or minus. So now from these two, what are my other 2 answers? Yeah, -1, +1, which we verified on our calculator. We knew that those should be the answer there. Questions about that? Let's go ahead. That was our last problem for this section. Let's go ahead, since we have a few minutes, let's go ahead and practice graphing that, because that's kind of reviewing all the other things we went over. Remember, to graph it, we need to know in behavior. We need to know your solutions. That was the hardest part. We already did that part. You need to know your y-intercept, and then you just put it on the graph. Okay, so what is the in behavior here? First of all, I looked at it on my calculator, but how do I find the in behavior? Remember? Degree. What's degree is what number? 4, which means it's even. What does even degree tell us? Go together, up or down, right? To figure out which way it goes, I look at the leading coefficient. Leading coefficient is 1. Is that positive or negative? Positive. Even, positive go together up. So my in behavior is rises on the left, rises on the right. The next thing I would find is my solutions. Check. 5, -3, -1, 1. Okay, so I'm going to put all those on my graph. None of them have multiplicities here. They all have a multiplicity of 1, right? So that means that they all just cross straight through. They don't do anything special. What's the max number of turns this has? Yep, it's the degree minus 1. So 4 minus 1 equals 3. And the last thing we can do is find the y-intercept. How do I find the y-intercept? Plug in 0 for x, solve for y. So that's pretty easy. F of 0 is going to be, I'm not going to write it out, 0, 0, 0, 0, 15. Right? Because all the terms that have x's in it are all going to zero out. Okay, so the y-intercept is 15. So I can go ahead and graph this on some paper. So let me get my other pen real fast. Okay, in behavior, I know it's going to end up going this way and this way. Okay, my solutions are -3. So 1, 2, 3. I have a dot there. -1, I have a dot there. 1 and 2, 3, 4, 5. And these all just cross through. The other thing I know is my y-intercept. What's my y-intercept? 15, so it's kind of high up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. My graph is not perfect, but you get the idea. Okay, so I know for a fact this graph is going to come up to here and turn down here. And the reason why I know it turns right there is because that is in the middle of my 2 intercepts, right? I know from here it's going to come up, and I know here it's going to come up. These 2 pieces are going to come down and make like the W, right? I'm fine with you just drawing those in. If you wanted to know exactly where how far they went, how would you find exactly how far they go down? Yeah, you could find the test points there. And there's a couple ways you could do that. One way is doing it by hand, plugging them in. The other way is this is already typed on my calculator, so I can look at my table of values, right? What 2 ordered pairs do we want to know? Right here in the middle of these 2, which would be -2. And in the middle of these 2 would be +3. Do you see why I picked those? Because they're in the middle and that's where it's going to curve. Okay, so since this is already in my calculator, I could go to my table of values. At -2, it's at -21. At +3, it is at -96. That's a big old graph. Okay, so we are not going to graph that. Okay, we're just going to show that it goes down. And it goes down even further. Okay, so not drawn to scale, but you get the idea, right? And the reason why you need to know that is because if you just try to graph this off your paper, you just see 4 lines, not your paper, off your calculator, you just see 4 lines. Like you got to know that it's a curve and it's continuous and it connects somewhere. Okay, even if you zoomed out, you still wouldn't be able to see it. You have to zoom super far out to be able to see it. Okay, so that is the end of polynomials. The next thing we are doing is rational functions, which are also super fun. They have a lot of things to memorize though. So it would be in your best interest to make sure you got all this down at this point, okay? So 3.5 is rational functions. On Monday, I'm gonna bring like a flashcard page. If you want to make flashcards of all the things you need to remember for this test, because there's a whole bunch of stuff, I feel like we know enough, and by Monday we will have seen almost everything at that point. So I'll bring that so you can start studying for that for your test. Your test is a week from this Wednesday. So Wednesday the 21st is your exam, and if you're on Zoom, remember you have to be in class, so plan to be in class that day. Okay. So y'all have a good weekend, and I will see y'all on Monday.